Hello, my friend. My name is Joshua Mugabi. I welcome you to Chemical Kinetics. The study of reaction kinetics is called rate of reaction, mechanism of reaction, factors which affect the rate of reaction, all of the mentioned above. The answer is all the mentioned. Reaction kinetics is the study of reaction rates, mechanisms, and the factors that influence reaction rates. The reaction rate constant can be defined as the rate of reaction when each reactant's concentration is zero, unit, doubled the initial concentration, infinite. And the answer is unity. The reaction rate constant can be defined as the rate of reaction when all the reactants' concentration are unity. The rate of a chemical reaction is quantified by a reaction rate constant or reaction rate coefficient, K. Which of the following is the right temperature coefficient and expression? N equals to rate constant at T plus 10 degrees divided by rate constant at T degrees. N equals to the rate constant at T plus 20 degrees divided by rate constant at T degrees. N equals to rate constant at T plus 30 degrees divided by rate constant at T degrees. N equals to the rate constant at T plus 40 divided by the rate constant at T degrees. The answer is N equals to rate constant at T plus 10 degrees divided by the rate constant at T degrees. The effect of temperature on a reaction space is commonly stated in terms of the temperature coefficient, which is defined by the equation temperature coefficient, which is given as N, equals to T plus 10 degrees, or 308 Kelvin, rate constant, divided by temperature rate constant, which is 298 Kelvin. When the temperature rises, what happens to the peak of the curve in the Maxwell-Boltzmann distribution graph? Shifts forward and upward. Shifts forward and downward. Shifts backward and upward. Shifts backwards and downward. The answer is shifts forward and downward. The peak moves ahead but downward as the temperature rises. This is because when the temperature rises, the most probable kinetic energy rises, while the percentage of molecules with the most probable kinetic energy drops. Plotting a graph between temperature and reaction rates can reveal the temperature dependence of reaction rates. Concentration of reactants and temperature. Concentration of products and temperature. Rate constant and temperature. Rate of catalysis and temperature. And the answer is rate constant and temperature. Plotting a graph between rate constant and temperature for various reactions can be used to investigate the temperature dependence of the reaction rates. What effect does temperature have on the half-life of the first-order reaction? It increases, it decreases, it remains the same. Both increases as well as decrease. The answer is it decreases. For the first order reaction, the rate constant increases on increasing temperature. But for the half-life of the first order reaction, the rate constant is inversely proportional to half-life. Thus, an increasing temperature, half-life decreases. A simple homogeneous reaction requires integration method, half-life period method, graphical method, also this isolation method. And the answer is integration method. For complex reactions, the integration method leads to incorrect conclusions, but the integration method is suitable for simple homogeneous reactions. In 30 minutes, the first order reaction is 50% complete. Calculate the amount of time it took to complete 87.5% of the reaction. "30 minutes", "60 minutes", "90 minutes", "120 minutes". The answer is 90 minutes. In 30 minutes, the reaction is 50% complete as a result of half-life equaling to 30 minutes. In 2 half-lives, 75% of the process is accomplished as a result of T equals to 2 times 30, which is equal to 60 minutes. In 3 half-lives, 87.5% of the reaction is finished. Hence, T equals to 3 times 30, which gives us 90 minutes. In a reaction, what is the driving force? Energy given, energy released, free energy, none of the above. The answer is free energy. The change in free energy, which is related to the equilibrium constant, is the reaction's driving force, K. What is the heat of reaction for ethyl acetate hydrolysis? Greater than 0, less than 0, 0, none of the mentioned. The answer is 0. The equilibrium position of ethyl acetate hydrolysis was demonstrated to be temperature independent because the bonds broken and created at the same kind Hello, my friends. Thank you very much for participating in kinetic chemical kinetics. Please do like, share, and subscribe.